column is saying like the height of the base is increasing by like 3 inches. Is that saying that it started from 0?
No, they actually told you. Yeah, on the original question, it told you. So you have to go back and do it. Otherwise, you will fail the next test. So it's really hard. The next test is really hard. So the second question, which is B, is like I think yesterday there was a question 3. There was a triangle, the base expanding and the height is expanding at different rate. This is that one question. So area equal to 1/2 base times height. In this case, it's 8x times y, and then you got dx dt y, x dy dt. So this one that you require to do product rules. I miss a parenthesis right here. So that's the idea. Now, for the next question is a little bit different. The next question says find the rate of angle between the ladder and the wall of the house. So this one's a little bit different. So you want to pay attention to like this small little part right here, because they say angles between the ladder and the wall of the house. So this one has to be the angle right here. I'll show you a different color. For part A, I already find out it's -7/12. Now for this part, I want to figure out how fast the angle changing. Do you think the angle changing is going to be positive or negative if I sliding down? So the angle is going to be positive or negative. D theta dt. Is it positive? It's just going to get wider, becoming more, going down. The bottom's getting smaller, right? So, and we did talk about the first day when we talk about all the relationship. When I give you a formula, when I say anything deal with angles changing, which kind of relationship I'll be using? Do you remember that? Look at the notes of all the relationship I give it to you. I says when angles changing, you're gonna think about SOHCAHTOA. Thank you. So the problem is you got 3 choices. You got sine equal to opposite over hypotenuse, or you got a cosine equal to adjacent over hypotenuse, and you got tangent is equal to tangent theta is equal to opposite over adjacent, right? And which choice I will pick in this particular solution? Actually, to tell you, all of them is possible, but which one's the best choice? And I also say something else when I talk about changing of angle. I also write that one statement. I don't know if you remember. When I talk about SOHCAHTOA, on the bottom, I say it's one statement I want you to pay attention to. What does that statement say? Make sure constant on the bottom. Thank you. So that is going to be based on your choices. So Vincent say you got a choice. Which choice you would do? Why would you choose sine?
You're trying to find the angle of the top, so the opposite, that would be the bottom. That's moving. And then the constant is the hypotenuse because it's the size of the ladder.
Right. Okay, so here's the thing. That wasn't the best choice. The second best choice is actually cosine theta. It can be done. The problem with cosine theta, I'm going to show you. The problem with cosine theta is it's more risky. And we talk about why it's more risky. Because the dy dt you get is from part A. What if you evaluate dy dt wrong? Then you're not going to get a correct answer. So then you have to pay attention to that dy dt. So I would prefer use dx dt, that's just me. So if I would set up a relationship, that would be sine of theta is equal to what? Well, 7 is not staying the same. So you should not use 7. Instead, you should use something else. You cannot use 7 here. Because you take a derivative of 7, it's going to become 0. It's changing. 7 doesn't always stay 7. Yes.
be a do dt?
No.
Would it be A?
Well, in this case, in yesterday's example, I use A. So in this picture, I'm going to use X. Is that okay? X over 25. Does that make sense? And do you see that constant on the bottom? Why did I say constant had to be bounded? Can I use cosecant? Yeah, but if you take a derivative of 25 over X, it's much more complex than X over 25. So that's the things that you want to think about. Now, I'm going to take a derivative with respect to time. If I take a derivative with respect to time, what am I going to get? What's derivative of sine theta? Yes. What else? There's something else missing. There's chain rule. It's one more thing, which is what we're looking for today. Delta theta over delta time. Now this, this is something that is missing. Don't forget that, because you got to take a derivative of the outer and take a derivative of the inner. Does that make sense or no? It's like a chain rule. But you take a derivative of the cosine theta, but you have to take a derivative of theta with respect to time. That's why you get d theta dt. Are we okay here? Now, how do I take a derivative of x over 25? Respect to time. It's easier than it looks. Come on, you guys are so afraid to make mistake. It's okay to make mistake. Give me the something. Huh? I won't do product rule here because the bottom is constant and it's a quotient, so I won't use product rule. I will use something called constant multiple rule. So what would it be? Yes, Amir?
1 over 25 times dx over dt.
Yep. Does that make sense? Because that's just 1 over 25 times x. If you write down 1 here, it kind of shows that. So you take a derivative of 2x is 2, right? Is that okay? Now I'm going to have d theta dt is equal to 1 over 25 times dx dt, right? Dx dt is 2 and 1 over cosine theta because it's divided by cosine theta. That's equal to 1 over 25 times 2 times secant of theta. Secant of theta is equal to hypotenuse. It's a ratio. It's a trig ratio. It should get a fraction. It's a hypotenuse over adjacent. So go back, look at a triangle. What is hypotenuse? Is 25. Adjacent is going to be, this is adjacent to this now. This is adjacent. So this, remember, we got from before is 24. So you should get equal to 1 over 25 times 2 times 25 over 24. And 25 will simplify it down. 2 over 12 is 1 over 12 radian per second. Most of you guys don't have an essence feel of radians because it doesn't make sense that you get a radian, but radian is a term of degrees. So 1 radian, those of you guys doesn't know how it feel, but 1 radian is roughly 57.3 degrees. You might want to write this down. 1 radian, and hopefully that makes sense, equal to 57.3 degrees. Why? Because that just means 180 divided by pi. This means 180 divided by pi. 3.14. So that is the degrees. That's 1 radian is equal to. I think Shapiro probably didn't mention this part as much, but a lot of people just take for granted because this part is kind of hard. I think about the third year I was teaching, I didn't know what does run radian mean. So even I was a teacher for a long time. So people ask me run radian, I was like, yeah, just radian, don't worry about it. I have no freaking clue. But until I was, reading more into it, I understand, okay, this is what I meant. Does that make sense? On your today's homework, you're gonna have to some type to deal with deltas, and you have to learn how to work with that. So that's the first video.